Thanks to everyone for joining today, and thanks especially to Becky Peterson and Refcomm for providing this platform for us to discuss octane destruction in FCC gasoline post-treaters. I am told we have 70 live participants, and that's a great turnout. I'm George Hoekstra. My company sponsors multi-client research projects in refining technology. We do full-blown research projects that include pilot plant testing, and these are the pilot plants we use for hydroprocessing work. They are owned and run by Sea Solutions Limited in Thessaloniki, Greece, which I can say with full confidence is the best place to do independent pilot plant testing anywhere in the world today. Our projects also include field testing to measure commercial unit performance and market analysis, which includes the regulatory, economic, and business aspects that affect financial performance. Our projects work on an annual cycle. Each year we do a well-defined project and issue an annual report in November. Annual reports 6, 7, and 8 cover our 3-year program on gasoline desulfurization for Tier 3 gasoline. Our annual projects cost $350,000 per year. Most of that is for generating new data in the pilot plant, field test, and analytical labs. Because these are multi-client projects, the cost per client is only a fraction of the total cost. All our reports are available for purchase by anyone at any time. Our reports include dozens of attachments like these, tens of millions of dollars worth of the best published research on the topic. They are included as attachments to our reports so you can become a true expert on that topic. The Tier 3 standard mandates a 10 ppm average annual sulfur limit on gasoline in the United States. It was enacted in 2014 and phased in from 2017 to 2020. Here I will cover the first topic, which is Tier 3 implementation. Is the industry ready? What's the problem? And what's going to happen? Is the industry ready for Tier 3? I say no, but this is a minority opinion. The industry consensus says yes. I will present some evidence here to support my contrarian view in the form of 4 metrics. First, capital investment for Tier 3. In 2014, it was expected that $3 billion would be invested in FCC feed pretreaters and gasoline desulfurizers in the United States. But when we look at our FCC trains today and compare them to 2014, we see no net change. There were a few Tier 3 projects in the industry, but with other changes, the net effect is 0. And I predict that some of the expected investment will occur in the future. Compliance can be measured by the average sulfur in the U.S. gasoline pool. The industry expectation was for early compliance, meaning the pool would be at 10 ppm sulfur long before the full requirement hit in 2020. Actually, compliance is late. The latest value reported by EPA 2 weeks ago was 17.5 ppm, which is a long way from 10. And I predict that when we reach 2023 and look back, we will say compliance was late. We can measure the cost of Tier 3 gasoline by the amount of octane that is lost in gasoline desulfurizers when refineries make necessary adjustments to meet a 10 ppm average gasoline pool. In 2014, that was expected to be 0.5 AKI octane loss. And AKI is anti-knock index, which is the octane measure we are familiar with in the United States. I believe the actual number is 2.5 AKI, 5 times higher than expected. And I predict that is where we will be in 2023. A fourth metric is the supply of Tier 3 sulfur credits. The 2014 expectation was that there would be an ample supply of Tier 3 credits by now because of early compliance. In fact, there is a meager supply of Tier 3 credits today, and I predict the sulfur credit market will remain very tight until 2023. If the industry is not ready, what's the problem? I say the problem is octane. I believe Tier 3 will cause billions of dollars per year in unexpected octane destruction that will have large impacts on refining profitability, like a replay of the impacts we have seen with ethanol RINs. I will cover this octane problem in detail in part 2 of this presentation. Given the octane problem, what do I think is going to happen? In a word, adaptation. Refiners will find ways to make things work. Here are some adaptive steps that are being taken today at U.S. refineries as they increase desulfurization severity to make 10 ppm gasoline. They involve purchases, downgrades, restrictions on operations, and foregoing sales of premium gasoline. These adaptations are costly and will substantially affect refining profits in the future. I'm going to pause here for a poll question. Is your refinery making over 10 ppm sulfur gasoline today? Please enter your response and we'll discuss the survey results in part 3 of today's meeting, the Q&A. In part 2, I will go deeper into the problem of octane destruction, showing much more evidence about my claim on the octane problem, which is the root of the issue.